Hey everyone, welcome to this session on DevOps for Azure SQL. My name is Arvind Shyamsundar. I am a principal PM at Microsoft working on Azure SQL database. It's my pleasure to bring this topic to you, and hopefully you have some background, some interest in the area. Maybe you want to implement a CI/CD pipeline or something of that sort. So hopefully you have some motivation to do this. And uh, if you didn't, perhaps the easiest way to kind of set the context and get started with DevOps is with a little anecdote. But before I get into that, uh, here's some background about myself. I think the main things you want to keep in mind are if you want to get back in touch with me about certain topics from this presentation. Um, I think the easiest way is to tweet, to use Twitter and tweet, question at me. This is my handle on Twitter. All the examples that I am showing you today are also on GitHub. I have a link later in the deck as well, which shows you exactly where you can find the same. So here's some background about me. I'm not going to read through this, but I've been at Microsoft for a while and focusing mostly on data platform products and mostly on SQL. I have also had some, in-depth work with Azure Databricks, Azure Data Lake Storage, and so on, more on the end-to-end data pipeline scenarios. Um, with that, so let me kind of start with this anecdote, as I mentioned. So if you didn't know what DevOps is, and if you didn't know what it means in the context of a database, the easiest way to kind of explain DevOps would be to use this phrase, which many of us, I'm sure, at some point in time have used intentionally or unintentionally, saying, hey, it worked on my machine. I don't know what's going on with yours or in production. So the whole point with DevOps is to improve repeatability, predictability, consistency, and auditability. And in the end of the day, we want to avoid us having to say this phrase, saying, hey, it worked on my machine. We shouldn't have to say that because we want to remove some of these unpredictable aspects and make it more machine driven, machine oriented, wherein you have a piece of code. It lives in a source control system. It is versioned. You have history. Uh, Deployments are done through a machine and not necessarily a person or a human being doing those actions. These are just parts of the principles behind DevOps, wherein eventually you want to improve predictability, repeatability, and a lot of other advantages, as you will see. So the way at present DevOps is kind of use the official, this is the official view that Microsoft has been using in various conversations with customers and in our documentation, wherein we present this life cycle of software. And this is the four big buckets wherein you plan your software development project. And again, notice I'm saying software, I'm not necessarily saying database, because this is a broader conceptual view of things. And one of the points I want to drive home with this presentation today is that a database is just, again, should be regarded as just another piece of software, wherein your database objects, the code that you write within the database, everything should be treated as code. And these are some of the principles that are being driven in today's world where these DevOps principles are being adopted. So again, considering the broader scope of the DevOps term, you have these four phases wherein you plan and manage your software project. So this would mean you have a project, a backlog, you have a cadence of sorts, maybe you're following like an agile or a scrum process, wherein you have sprints and so on and so forth. So all of that goes into the planning bucket. Planning is all about your software project lifecycle at a higher level, project management in simple terms. Again, I'm simplifying things, but conceptually that's where it would go. Then the second big bucket is develop, where you're writing code. And again, this could be databases code. This could be infrastructure artifacts, like you're creating a SQL server in Azure, which is a logical SQL server. That's, again, should be expressed as code. You want to write a stored procedure within Azure SQL, you have code. You have database triggers, you have functions, you have indexes. All of these are code artifacts. And these live side by side with your software project proper, wherein you have a web app or a REST API or even some other type of a Windows application which is running on a desktop or something of that sort, or a mobile app which is consuming data from a database or something. So all of that is your code, and we will show you in this presentation some of the how all these tie in, wherein you can have different development environments like Visual Studio, Visual Studio Code, or even third-party IDEs. How do those tie in with this life cycle of DevOps? So develop is your code in simple terms. I'm trying to make it as simple as we can from a database point of view. So plan is project management, if you may. Develop is your code, your database artifacts, and everything that lives within the database, if you may. Then delivery or deliver is the third bucket. That's the process of deployment in simple terms. This is taking your code and either incrementally updating a target database or deploying the database in the first place, like from scratch. So deliver is, in very simple terms, corresponding to our acts of deploying into a production environment or a UAT environment or even a dev test type integration test environment. And then the last logical step is you've deployed your code. So you planned, you built, you deployed your code, and now it's in the run state. And it'll continue to be in the run state for a while. So operations is perhaps what many of us are most familiar with, wherein you have a steady state of a database, it's running in production or in some UAT environment. You have production type problems with it. Sometimes you have performance issues. You have to investigate certain logical or functional issues, so on and so forth. But hopefully, most of the time, it just runs fine. So operate is a very, very big bucket of activities and tasks. And perhaps that is a topic on its own, where you're looking at security, you're looking at monitoring, you're looking at lots of other aspects of running a database in production. And then this cycle continues to repeat. Your users need new features, so you plan for those features through user stories, tasks, and the backlog. You assign developers to work on those, they write code, then they deliver that code, and it continues in the cycle of operating, planning, developing, and delivery. So this is like a formal or a neutral view of the life cycle. But the key messages I want to kind of say at this stage are that we want to treat the database as just another piece of code. Eventually, that's the whole idea behind expressing everything as code, infrastructure as code, databases as code, and then you have your applications, of course, as code. In today's presentation, given the time and the scope that we want to deliver, we will focus on development and delivery. And specifically, what what aspects we're going to talk about are things like version control, collaborating with the other engineers where you have a bigger team. How do they work together? What kind of considerations do you keep from a database development point of view when it comes to code quality analysis, code analysis, code quality, and things like language support and so on. We will also spend most of our time actually today in looking at the delivery aspect, which is what are the options we have from a tooling perspective to take a database in terms of code and then deliver that into a target SQL Server database where you have pipelines, perhaps, which are ensuring that the deployment is repeatable. Another key aspect which you will perhaps be familiar with is when I say repeatability, in some cases, it is what we call as idempotency. Idempotency is a characteristic wherein a deployment, if done twice, should not do the same change twice. It should skip the change if it's already in place and so on. And then other aspects around how do you manage secrets? How do you make sure that you don't expose passwords? You don't have other hard-coded secrets in your code. And how do I go back and see what was deployed when and what changes happened along the way, which might have affected particular system which is running. So these are the two areas that I'm going to spend time on today. And as I mentioned, I'll probably be spending more time in the delivery bucket because the develop bucket is again quite varied and can be a space on its own. So with that conceptual kind of introduction and background behind us, as I mentioned, there's going to be a lot of code I show, and all the projects that I am going to use are actually on GitHub. I can just quickly show you. So if you go to GitHub/Arvind Microsoft, and that's the repo that I am going to be using. So there are a few projects here that I will be demonstrating as well in the form of a couple of demos. We'll come to that in a minute, but just be aware that all this is available for you for a reference after the talk is over. And to make most out of the talk, we do expect you know some basics about databases. You're hopefully familiar with developing in T-SQL. You know some of the concepts with Azure SQL, like we have a logical SQL server, we have a database, and then you have the objects within the database. And Git is useful to know because, again, you will find version control. Git is today the most commonly used system, and I'm going to be using Git in conjunction with both GitHub and Azure DevOps, which is the Microsoft tool of choice. As I mentioned, some of these other buckets, like operations especially, is a vast topic on its own. I'm not going to be covering that in detail, but I do want to point out there's a related presentation one of my colleagues, Denzel, has given at this event, which is talking about performance troubleshooting and tuning, especially for Azure SQL Hyperscale. So do take a look at that talk, and Denzel has a nice performance monitoring dashboard as well, which would be of interest to you. And the other thing you will find me staying away from today is trying to give reference architecture or reference implementation or a specific one-size-fits-all type recommendation, because as you will see, there are lots of options for implementing these principles, DevOps principles in your environment. And many times these are going to depend on other aspects within your environment. Maybe your company already has, or organization already has certain preferences to implement in a particular way, maybe from a process point of view, maybe from tooling point of view. So it is very difficult to give like one recommendation, especially for like a DevOps lifecycle. But my hope is that you get an idea of what's out there and what are the considerations when you will use each type of tool or process. So this is view this talk more as an educational overview rather than like a very prescriptive implementation specific discussion.
Arvind?
Cool. Yeah. Yes.
Quick question. Actually, I think if you can go to the next screen, would people need knowledge in Visual Studio or VS Code?
Okay, it's useful. As you'll see, I have a couple of demos which do use VS Code, but it doesn't need only VS Code. You can have a third-party IDE. Maybe you're using IntelliJ or some other environment completely different from the tools that I'm going to use today. And again, as I said, it's just an example. You could do some of these things with a third-party tool as well, especially if you're on Mac or let's say you're on Linux or something. You could potentially be using a very different IDE. So
okay, thank you.
Thank you. So what I'm going to show you today, and again, I'll try to spend as much time going forward as possible in the demos. We will see two demos in action. And just to give you the background on the demos, we want to show a very simple example of a change to a database. And that's basically what we want to show you. We have a sample database and a sample application which using the database. And this is a simple fitness tracking application. This was actually developed by one of our colleagues, Anna and she also again has presented at this event. So Anna has a very simple example on her GitHub repo, which shows how to use an application for fitness, for tracking fitness. And again, this is make-believe. It's a kind of artistic improvisation, but consider that there's an application which is interfacing with uh, some handheld device where you're tracking your steps and so on and so forth. And let's imagine that the application is communicating with certain components in Azure. So you have an app, which is on the top here, that's communicating with a REST API, which is a way to, it's a web service. And the REST API actually talks to a database. So in this demo, in a couple of demos that I'm going to show you, I'm going to have a simulated version of the REST API, which is able to, at least report your fitness activities for now. If we just show you that in a minute. And the data for that fitness app is in an Azure SQL database. I'm going to show you two flows of how to make changes or how do you deploy, how do you develop and deploy these changes to a database. I'm going to show you a flow which involves using Visual Studio Code, which is one of our most popular free environments for development. And that VS Code will be using a public, tool, which is GitHub. Everybody probably knows about GitHub. And within that, I'm going to use a private repository. So GitHub allows you to create private repositories, which are great for enterprises to use. And again, in that first example, I'm going to show you a third-party library, which is called DbUp. DbUp is a .NET library. It can be used to perform migrations. And migrations in this context means changes from one state of the database to another. So you'll see this in action when we look at the demo. So that's one flow. And the eventual goal is to deploy those changes to that database, which is in Azure. The other more complicated scenario I will show towards the end of our presentation is we have Visual Studio 2019, which some of you might have heard about, has this thing called SQL projects. In the old days, we used to call this SSDT. SQL Server Data Tools. That name SQL Server is kind of confusing because then you start thinking, hey, this is only for SQL Server. Maybe it's running in a VM or on premises. And the interesting thing is the tooling there actually supports Azure SQL as well. So the key thing we want to emphasize, and again, I'll repeat this towards the end of the presentation, is we are now calling this SQL projects to make sure that people understand it is also for Azure SQL. Anyway, so we'll use this IDE, and I'll show you some stuff like, it can do code analysis, like code review, and actually flag some anti-patterns or bad coding practices or some interesting coding practices that you might sometimes not detect manually. And then we will use Azure DevOps, which is earlier, again, known as Visual Studio Team Services or Visual Studio Online. Azure DevOps is today a very popular option to orchestrate a lot of the phases that I described to you in the DevOps lifecycle, which is you can plan your project, you can develop and store code there, you can deploy, and you can also use it to do some integrations with monitoring tools as well. And for the second demo, I'm going to use this thing called a DAG pack. Some of you, again, might be familiar with DAG packs. DAG packs are these artifacts that are produced by tooling like Visual Studio, which is essentially a zip file. It's basically a zip file with a copy of your database expressed as a database model. It's not a set of SQL scripts. So what happens in DAG packs when you deploy them to a target SQL database is that internally, the tooling that's doing the deployment, which you'll see again in the demo, but we use some tooling called SQL package, which is also supported by a framework called DAGFX. That framework internally generates a diff between what's on the target and what's in your project, and then incrementally change the database to get to that final state. So the reason I'm showing you these two demos or two flows is to contrast as well the different types of database deployment or database development philosophies that are out there. And DbUp is based on a philosophy where you incrementally specify the changes as a set of alter commands, like alter table or alter procedure, and so on and so forth. With DAC packs and with SQL projects, you do not specify alter commands. You just say, I want to get to this state wherein the table has this column in it. And DAC effects and SQL package, which are the tooling behind the scenes, they figure out how to change the database to get to that state. So they will create the alter statements for you, and you generally do not have to worry about the how. Um, Another simple way to imagine this is if you look at tools like DbUp and you look at tools like DACPack and SSTT or SQL projects, the difference is very similar to if you wanted to eat pizza. And if you want to eat pizza, you have two options. You can make it yourself, or you can call and buy pizza from some online shop or some some pizza shop. So the this is a very simple but very crude analogy, depending on how you look at it. But if you look at the analogy of making your own pizza, you typically have to you have to know the steps. So you need to write all the you need to follow all the steps to make the pizza. You need to make your own dough. You need to make sauce. You need to get ingredients for toppings and so on. So that's like this DBUp migration or migration-based philosophy, wherein you specify the changes. You need to, describe the how. How do I get to the final state? So that's DBUp, the first demo that I'm going to show you. The second option is like you call a pizza shop, and you just say, I want this. You tell me, you get me the pizza. You make it. You figure out how to, ship it to me, and I just want to eat the pizza at the end of the day. So DAC packs simplify that experience to a certain extent, at least by design. That's what they intend to do. They wrap up all the how, and they don't need you to bother about the how. What instead in a DAC pack or in a SSTT or in a SQL project world, what you do is you specify the what. What do I want? I want to get to a table which has these columns, and DAC effects internally and SQL package internally figures out the how. So keep that in mind. If you have never heard about DAC packs and SSTT and all these things, just remember that they're like the buy pizza from some shop analogy. And if you want to roll your own, it's the first example, which is like this DbUp, ready roll, which is from Redgate. And you have many other tools like Flyaway and so on and so forth. They all fall into the make your own pizza category, if you may. So it's a simple analogy, and I hope it's useful to visualize why these two different styles of database development and deployment.
Arvind?
So yeah, Steve.
In one sentence, what would be the difference between GitHub and Azure DevOps?
Great. I think GitHub is obviously very popular. It's a public site by origins. But I think it's hard to summarize it in one sentence. But I can say this much: I think GitHub came more from source control background, and they are slowly but surely adding more and more features. Like they have added project management type features. They have added issue tracking, of course. They have added actions, which is like pipelines and CI/CD. Azure DevOps classically comes from, again, source control background, but it has been around a little longer from the commercial space, and it focuses a lot more on all four phases of the DevOps lifecycle. So you will see, and I'll show this to you in the demo in a minute or two, you will see a lot more emphasis in Azure DevOps on project boards, on things like activity tracking for tasks when you want to assign tasks to developers, sprints, all the software lifecycle aspects, in addition to source control, in addition to pipelines, in addition to other extensibility, like you can add code compliance, things and so on and so forth. So I think
is it fair to say that Azure DevOps is more comprehensive solution?
For now, I would say that. I
Okay.
think over time it's going to blur because one of the things, for example, to distinguish between the two is earlier with GitHub, you could not do private repositories unless you paid and you use their enterprise option. So you know, GitHub added private repositories for free. You can have a certain number of private repositories for free. Recently, they allowed that, and over time, as you know, and most of you probably know that GitHub is now a Microsoft company. So when I say they, I actually I shouldn't be saying they because they're also part of Microsoft. I mean, GitHub is a Microsoft entity, but GitHub remains independent. They're a completely independent organization. That said, uh, GitHub Actions, as I mentioned, which is the CI/CD pipeline option within GitHub, is very close. It's very similar to Azure DevOps pipelines, Azure pipelines as we call them, and you'll see this again in some of the demos. So over time, I see more convergence. And who knows, right? How the future will pan out? Maybe these things will become one thing, over time. But for now, I think enterprises tend to prefer things like Azure DevOps because it has a little bit more full-featured capabilities on the project side of things. GitHub is free. Azure DevOps is also free for smaller enterprises, like you can have for free if you're 5 users or less, and things of that sort. So it's a matter of personal preferences. Also, some people like GitHub because it's open. It's been open for a while, and it's a matter of principles. Sometimes people don't want to buy commercial thing like Azure DevOps. So I think in the end of the day, the capabilities will merge. GitHub Actions is becoming more and more mature. It is becoming closer to what Azure Pipelines, for example, offers today. So there's lots of shared plumbing as well. So GitHub Actions actually runs on Azure in the backend. They have we have VMs which are shared shared between Azure DevOps and GitHub Actions. So there's a lot of commonality which we are seeing, and I think over time we may, who knows, right? We may see some merger of sorts. So the future will only tell.
Okay.
Hope that answers.
Yep. That was a great answer. Thank you. One more question. I see that there is an example. Maybe this is just an example that's showing that there is going to be deployment to Azure environment. But what if people, and I think this is 50% or more, they're still running something on-prem.
Sure.
Even if it's in the cloud, they may be running it as a VM. So you would still use Azure DevOps to deploy to.
Sure. Yeah, you totally can. And I think especially with the first method, DbUp, I'm just giving DbUp as an example. You could use a third-party library like Easy, like ReadyRoll or Flyaway as well. With those tools, in the end of the day, they just need a connection string. So that connection string could very well be a SQL in a VM instead of an Azure SQL DB. The second flow that I'm showing today is using SSDT and DACPack. We're going to use something called a DACPack deployment task. That task internally just runs SQL package.exe, which again just needs a server name and authentication to connect to the server. So as long as you have connectivity, and this is again one part of my demo is to show you how we run a self-hosted agent for this Azure DevOps workflow. That self-hosted agent could be running in your data center. It could be running on premises in a virtual machine somewhere. So you can totally use the same flow to deploy to a SQL server, which is running in a VM or on bare metal on your premises somewhere. So the principles are the same, and connection strings in the end of the day and network connectivity will be the crucial things to consider. I think in that case, again, I have a little bit more experience running with Azure DevOps self-hosted build agents on premises, for example. I don't know for sure if GitHub Actions allows you to do self-hosted runners, which are actually agents on premises, for example. There might be a way. I'm just not sure about GitHub, but it can totally be possible to deploy to a SQL server. Hopefully, that answers your question.
Yep, got it. Thank you.
Okay, so cool. Let's move on. I think so. Hopefully, this sets the context, right? Remember these few analogies that I mentioned. They help you, I think, to visualize. Remember the first code path, if you may, or the first workflow is more like building your, cooking your own pizza, and the second one is more like you order a pizza. So very simple analogy of you doing the how, like you specifying the how in the first case, and in the second case you just specify the what. What do I want in the end? And you figure out how to get there. So with that background, let me move on and I'm going to breeze through the next 2-3 slides because they were more intended for reference. They were not really intended to be talked through in depth, but briefly talk about some of these. So as I mentioned earlier, for each of these buckets like develop and deliver, that I mentioned at the beginning, we are going to focus on. There are lots of tooling options, and these are just some of the examples that I can provide you. There are many options. We have seen, we have talked about the first two briefly. The differences between Visual Studio Code. Visual Studio is still commercial software. It runs on Windows. Visual Studio Code actually can run on Mac. It can run on Linux as well. You have Azure Data Studio as well, which can be used on Mac and Linux in addition to Windows. Most people that I see in the Microsoft world tend to use Visual Studio for database development, but then increasingly we are seeing more and more customers and users using Visual Studio Code with frameworks like DbUp, Flyaway, or such third-party options. Some people obviously still develop with Management Studio. Again, totally fine. If it works for you, great. But from a robust code-oriented point of view, I think most users that I've come across tend to use one of these two tools. VS Code is free, again, just to re-emphasize, and it works on all operating systems, at least the most popular ones, Mac OS, Linux, and Windows. Some of the options that we are going to look at today, DbUp, I'm going to show you in the demo, Flyways from Redgate. These are all frameworks. They are libraries. They are like programming frameworks which you can use to incrementally change a database. From a commercial software point of view, there are many, many options. I have just listed a few of the popular ones. Redgate is very popular, SQL Change Automation, SQL and Lite. These are all, again, I don't want to say one is better or not from the other because they are all, in the end of the day, good in what they do. So it's up to you to decide which one works for you. Again, breezing through this, the coding, and then you test, right? So testing is a big, big topic in itself, and I don't think I do justice to it in this slide deck. But that said, keep in mind that there are certain frameworks for unit testing. And integration testing, of course, you could run a more elaborate framework of actually deploying a database. You deploy an application, and then you use some application level testing as well. But just to kind of educate those who are not aware, I think T-SQL-T is the most mature of the lot from a frameworks perspective. We seem to have a lot more users and customers considering T-SQL-T. Visual Studio also has some test coverage for SQL Server and SQL DB projects. Again, it's a matter of which one you are most comfortable with. I just want to paint the options. The one thing I do want to call out, though, is testing is usually dependent on test data. And one of the most interesting frameworks that I have seen for generating test data is this open source tool called Bogus. In the repo that I mentioned to you, I have a sample project which shows you how you can use this framework called Bogus. Again, it's C# code. It's a .NET code, but essentially these libraries like Bogus allow you to generate some fairly realistic and very, very efficient way of generating test data. So do keep these in mind because in the end of the day, testing is a very big topic. you have to have framework. You also have to have test data. You also have to have tests. So big topic, but just to be aware of some of the options here. And then comes code analysis. In my opinion, again, this is where the two approaches of, remember what I mentioned a few minutes ago, where we talked about build your own pizza or make your own pizza versus order a pizza. So if you're building your own pizza, you'll typically, the tendency is you'll use a change-based approach. As you'll see, there are some options out there for reviewing the code as you go along. But again, this is oversimplification. But think about it this way. If you were doing nothing but producing pizzas all day, and you're a company that does that, or you're an agency that sells pizzas for a living, you're probably going to have some robust quality analysis or QA type tools. So what I do want to mention is if you use SQL projects or SSTT, as many of us call it, we have a lot of options from a code review, code analysis point of view, and you'll see that in the demo that I'll show briefly. There are some open source tools which plug into SSTT or SQL projects, and they allow you to uncover some coding patterns or harmful or suboptimal coding patterns. Again, a lot of these are third party and open source. They are on GitHub, as you can see. And use them at your own with your own degree of comfort. Like some of them may actually have false positives wherein they're not really flagging issue, which is genuine. But then consider the fact that these are free, right? So you have to balance what is good and what is useful versus some of the things may be a little bit of noise. So you could not use some of them. Again, there are plenty of other options from the commercial space as well. But I'll show you briefly some of these open source options with SSTT. And the last thing, I think we talked briefly about this when Steve had a question earlier. What's the difference between GitHub, Azure DevOps? Both of these are Microsoft options today, even though, as I said, GitHub is a independent company in a practical sense. We are seeing more and more convergence. As I said, you'll see this in the demo again. Other options that we see from third parties, Atlassian is very big, GitLab, these are all popular. Again, Jenkins has been around for a long time. A lot of customers use Octopus to deploy backpacks, for example, into an Azure SQL database and so on. So these 4 slides that I had are more for reference. They're not really, you can't really do justice to looking at all of these in one single presentation, but just keep those in mind. The last thing I want to do before we get into the demos is take a task-oriented view. And this is more practical and pragmatic when it comes to the DB development lifecycle. So let's say I have my code. I have databases. I have objects within the database. I want to look at what are the tasks I want to do with those databases. So from a SQL DB perspective, Azure SQL database perspective, there are certain steps that you'll need to do to get a database in the first place. So you'll need to create an Azure SQL Server, which is a logical SQL Server. You will have an Azure SQL DB, which is the actual database that your objects go into. Then you might use the order a pizza option, which is you build a DAC using SSTT, for example, or you use a change-based tooling like DbUp or something else. Now, each of these steps have technology options. So this slide, again, it's more for reference, but I wanted to present it because it gives you an idea of the broad set of options that you have. To create a logical SQL Server in Azure, you could use ARM templates. You could use CLI. You could do PowerShell. You could even use third-party tools like Ansible or Terraform. Terraform is very popular these days. Similarly, for creating a database, you could use any of these kind of tools out here. We are going to see in the demo, we'll use MS Build to actually build a DAC and deploy the DAC using related set of tasks. In Azure DevOps, we can use the SQL deployment task and so on. So this task-oriented view can be useful, in my opinion, when you're considering choices and when you want to actually settle on an implementation tool of choice. So with that, again, we can take a quick check if there's any questions. Otherwise, I will get into the two demos and then we'll wrap up.
Arvind, can you please go back to one slide back?
The task-oriented view?
Yes.
Or, okay.
Yeah,
okay, sure.
that's the slide.
Okay.
And out of all the tooling choices, which ones are included with Visual Studio, or essentially included in the Microsoft software? MS Build?
Yeah. So MS Build is inbuilt in Azure DevOps, and you can also use it from GitHub if you use GitHub workflows or GitHub Actions. You can do a MS Build as well. I'll show you an example of that in the demo. So that's inbuilt. I think, let me see if the only third-party ones are the ones I've called out, like Terraform or Ansible. And everything else here is included in one way or the other. You don't have to buy anything.
Okay, got it.
You might have to install stuff. Like, for example, PowerShell. Some of these commandlets, you have to install the PowerShell SQL Server module. But again, that's free, and you don't have to pay anything for it. Even Ansible or I think Terraform also is mostly free, if I'm not mistaken. I've worked more with Ansible than Terraform, but Red Hat makes Ansible for free. So a lot of these options, you really don't have to buy anything. Most of these are just installable libraries, or they're included in the platform. So hopefully that answers your question.
Yep. Thank you.
Okay, sounds good. So let's walk through the demos, and these will be quick. I think again, I've done some pre-seeding of the of the work we want to show you, and let me make sure I set context again. So the first demo that I'm going to show you is the example that I mentioned is like build your own pizza, right? So this workflow wherein we have code, we're going to use GitHub, and we use DbUp to deploy into the database. So I'll simplify things, and I'll just show you, the most important elements. So this is Visual Studio Code. It is a free development environment, which it is more like it's a editor. It also integrates with Python and other things, which if you want to run local, like test scenarios, you can debug code locally as well. But in this case, what we've done is we have a database deployment project, which is called Fitness DB, DbUp. This is actually a C# project, which may seem surprising initially, but it's actually a very simple C# project. All that it does is it takes a connection string from some environment variables, it connects to the database, and it deploys a bunch of SQL scripts. When it's deploying the SQL scripts, it uses certain other environment variables to replace placeholders within the SQL scripts. And then it actually runs that script against the database. Now, this is using a third-party library, which is a free library called DbUp. Again, I don't want to say that I'm vouching for DbUp or recommending it. I'm just presenting an example, right? In the end of the day, you have to make a choice what you prefer. Now, DbUp, what it does is it has a lot of logic internally. What it does is it looks at the SQL scripts that you have specified. So for example, in this case, it says, oh, go to this folder, which is called the SQL folder, as you can see on the left. Look at all the SQL scripts there. And for each of the SQL scripts, it looks at the file name. And it has a tracking table in the database. So if I can just quickly switch gears, this is a database that was deployed. So this is an Azure SQL Server, if you may. This is an Azure SQL database. This is the same database that is produced by the DbUp project. And as you can see here, there are two tables. One is the actual table that is of interest from a business point of view, which is called the training session. It's a fitness tracking table. But this table is created for you by DbUp. And if you actually select data from that table, you'll see the script names. So you'll see here there was a set of scripts that was run on the 18th of August, a few days ago. And there was another set of scripts that was run on the 28th, which is today, just to kind of keep the distinction. So consider this as an initial deployment where we had certain data deployed into the database, and then we added some more data to it and changed the scope of the data or change the structure of the database. This is kind of background. And the reason I showed this to you is because DbUp actually uses script names or the SQL script file name and uses this schema versions table to track which file was applied or already applied. And if it finds that you're running a deployment on the same database for the second time, the first thing it does is sees which scripts are already run, and then it can skip or it can apply incremental changes. If you look at the actual SQL scripts themselves, they are very simple. The first set of scripts that went in, this is the very first script that you'll typically deploy because it's called 01, so it goes in sequence. And you'll see some funny things here, like it has a placeholder, SQL password, $SQL password. What is that? And if you go back to the C# code that I mentioned briefly, remember there was a placeholder for an environment variable. So secrets management. So this is basically saying, hey, in your script, in SQL scripts, if you see this variable called SQL password, actually fill in the value from environment variable. Now, an environment variable is set in the context of an operating system shell. So if you're running Windows, for example, this is like a DOS, like an environment variable. If you're running Linux, it would be a shell script environment variable. So DbUp takes care of all of that for you. It takes the environment variable and replaces these internal SQL variables with the actual value. The reason this is important to call out is because, as I mentioned earlier in the slide deck, we want to make sure that we're not hard coding secrets. We are not exposing any passwords in the clear. So the first few scripts are essentially just creating objects within the database. The exact code is not important, but what I want to show you is that the code says create or alter when we first created the stored procedure. In a subsequent update, the developer added a new change to the stored proc. What the person, when they developed this change, was they added a temperature column, which is out here. So this is a new field in the table. So let me maybe backtrack a little bit. The first version of the table, if you go back here, the last column was adjusted distance. The next version of the table has added a temperature column. Now you'll see here that it is the change script is actually an alter table itself. And this is, again, going back to that analogy of the pizza. This is like building your own pizza. You want to add a topping, you want to add something else to the pizza, you got to make the change yourself. You have to tell, how to make the change. So this is how DbUp operates. It takes your scripts, it sees the ones that are new, are not yet executed on that database, and then it just blindly executes the scripts for you. You have to take care of the how. If this script had a problem, if it had a logical error or even a syntax error, DbUp is going to fail the deployment. It runs all of those deployments within a transaction. So there is not a risk of partial changes, but you have to do a lot of the heavy lifting and validation that these changes are migrated correctly. I'm going to fast forward to how all this comes together in a DevOps world. So you saw the program that's running, right? This is the C# program. It's going to take those scripts. It's going to use DbUp, and DbUp is going to then look at the tracking table and then apply the changes which are required. How does this all come together in a workflow, in an actual CI/CD type environment? So what you see here is a GitHub workflow. GitHub workflows are essentially software pipelines. They are a set of steps. They're a set of activities or tasks that are to be done by an agent that's running in the context of GitHub. And in this case, this workflow is going to be run on one of these conditions. So you either push changes. So again, this is why I said you need to know Git if you really want to make the most out of this session. But if you push changes, so you made changes, you're pushing to the branch, or if you opened a pull request to merge your changes to the other branch. And in this case, both these target the so-called master branch, which is the main branch in this case. So this workflow is going to trigger on one of these two actions. What the workflow actually does is it's going to run on a VM, which is running Windows. So you can also run on Linux if you wanted to, but in this case, I assume that I want to run on Windows. If you look at the next few steps, the few steps that are there are to actually get the project. So you check out the project. So it's like Git. You can actually pull and check out a branch. So you actually get your code. You get the code on the build agent, which is running on this GitHub VM, and then it builds the .NET project. In this case, the C# code was running as a .NET Core project. You could have, you could alternatively have a full framework based build action as well, which again, going back to your question, Steve, was you use MS Build in that case. In this case, it's just going to use .NET Build, which is .NET Core. So you have to tell it what version of .NET you want to use, and so on and so forth. And then the most important thing is actually running the code that's built. So if you can see here, we're running, we're running the .NET project. We're saying run. So run is the name of a task or an activity in GitHub Actions, and it's going to say run this fitness DbUp project and pass in these two variables, which are the environment variables. So you see here it says, oh, set up the run action with these environment variables. And if you notice, this syntax is a little funny. If you've not seen it before, this is a double kind of curly bracket type syntax. And you'll notice here it says secrets dot connection string. So I just want to tie this back to GitHub, and so that it all makes sense for you. So when I go back to the GitHub repo, first few things. So this is GitHub. Again, you'll notice it says private repository. As I mentioned earlier, GitHub makes available private repositories for free today. Anyway, so the thing is, this is a repo. It's a repository within GitHub. It's on this organization. And in that repository, I have set up certain secrets. These secrets are the connection strings to the database and the password. So if you navigate through this, you'll actually see that I have predefined these secrets. And these secrets are exactly what are used in the pipeline to populate those environment variables. And those environment variables are what are used by the program, as you saw earlier, to connect to the database and to populate certain predefined variables with. So that way you don't embed any secrets in your code. You leave all of that to like a secrets management store within GitHub. The last thing I want to show you in this before I pause for questions is look at the action itself. So I want to show you two workflows. So you recall, as I said, there was a deployment done 10 days back, which is like the baseline deployment. And there's another action which ran today, just before the session. So if you look at the first action, and I click through on the details, I'm going to focus on the run step. The run step is where it actually did the changes. And if you look at this, there's a few things I want to show you. It's running on Windows, as you can see. It's using Windows. And then you'll see these secrets coming through, which is good. And they're all obfuscated. They're not shown in the clear, which is further verification that these secrets are working. And then all of this stuff looks like it's coming from a program. You'll see it's saying, hey, the journal table doesn't exist. The journal table is that schema versions table that I showed you, which is the list of all the scripts that are run. And then it actually executes the scripts that are supposed to be executed. So this was done, all of this was done for us for free by DbUp. DbUp simplifies these changes to be deployed on the server. And as I said, if something goes wrong in middle, DbUp runs all of these within a transaction, so it'll roll back the whole change if it's feasible. If you're doing something which which can't be rolled back, then of course there's a different problem. But most of the time you're doing stuff within the database, so it should be transactionally recoverable. So this was the first workflow that was triggered a few days ago, 10 days ago. Today, when I ran in preparation for this session, I ran another instance of this change. And this time I actually added the temperature column. And the temperature column, when you look at it, it again does the same things, which is it gets your project, builds it, and runs the DbUp software project, which is, hey, now we have the journal table. You'll see it says, oh, we got a journal table, and I can determine what scripts have already been executed. And then it actually runs only the change, the new change script. So it's going to run 04, 05, and 06 as compared to 1, 2, and 3, which ran already. So this is a very simple mechanism. If you actually think about it, this just makes it easier for the developer to focus on their changes and not have to worry about the orchestration of all the change scripts. So it's a very simple but very effective way of deploying changes to a database. And if you noticed, it is run as a .NET program. So in the end of the day, you could run this as part of a bigger database, a bigger application deployment where you have changes to the app as well. So hopefully this gives you a brief idea of the first example, which is DbUp, and the build your own pizza kind of an analogy, if you may. So I'll pause for any questions. Otherwise, we can go on to the second and the last demo for today.
Question about your example of ordering a pizza or making a pizza.
Okay.
Is it also comes in the form of different price? So usually ordering a pizza requires more. So would your second option actually going to cost more?
It's a good point, and I think the way to imagine this is yes, there are overheads with SSDT or DAC and associated deployment method. With this method, it's very simple. The change is detected based on the list of scripts which have already been run. With DAC or SQL package or the DAC pack deployment, the cost of determining the changes which have to be done is significantly higher. And the way DAC does that is it actually imports your target database schema completely. So it has to script out your entire database. It builds an in-memory model and then does a schema comparison in memory between what is on the server and what it should be. And once it does the schema compare, it can produce an alter table script or an alter, whatever, right? It has to build the changes. So this is expensive in terms of computation. It's therefore slower than a simple approach like DbUp, for example, would take to run. It is also more complex because it has to actually reverse engineer the target database. It has to then do the diff, which is a schema comparison, and so on. So it's a lot more computation. So it's a little slower. It takes a lot more time in complex databases and large databases from a schema perspective. So yes, in simple terms, yes, it will cost us more in a computation sense to do the DAC pack based deployment.
Okay, but dollar-wise is the same.
It is otherwise, yeah. It's just time. And time is money for some people, so it does have that implication.
I've seen in your example using create or alter, and obviously for DbUp, it's up to you to make sure that's going to be runnable.
That's correct.
The DAC pack that it creates the script. It's smart enough to see that it's basically taking a script from 2014, trying to deploy to 16, because create or alter is, I think, available only from 16 Service Pack 1.
Perfect.
So DAC pack is smart enough to know the difference between versions as well?
Yes, sir. So I think that's a good segue to our second and last demo, which is DAC and SSDT or SQL projects and DAC packs in general. So I have open. I'm sorry, Steve. I think hopefully that answers your question, but I'll segue into this, and hopefully that'll help answer your last question as well. So so this is SSDT as it used to be called. I'm just going to call it Visual Studio SQL projects today. So when you have a SQL project, first of all, you'll see this is the baseline SQL project. So it's like having just the basic, change tracking table, a stored proc, which is just a create procedure, and a sample set of data that we want to insert. Now, when I go back to your question, which is how does SQL know what syntax will work or not? So if you drop this down in the project settings, you'll notice that it has sort of options to specify which version of SQL you want to target. And this can be changed, even on the fly. You can change it in the in the SQL proj file. But that is how it determines if syntax is valid or not for the destination database. The other remark I want to make is that generally speaking, when you do, let's take create procedure as an example. If I do an alter table here, it'll complain. It'll say, hey, alter is not supposed to be used, because all that you need to do here is just specify create. So SSTT or SQL projects imposes on us a declarative way of thinking, wherein we just state what do you want to get to finally, and that's always going to be creates. So I will never use a create or alter. In fact, I haven't tried it, but I think if you do a create or alter, it might complain because it doesn't like that syntax. So all that you need to do is just to create procedure as though you didn't have anything in the database. I'm just changing, I'm just creating a procedure up front. So you'll always use creates as much as.
And this is true also for tables. Now, for procedures, it's obviously not really a big problem with drops and creates. But for tables, for existing tables, I think it's going to be really bad if this is actually going to drop the table and create.
It won't. And that's a very good point, actually, which you bring up, Steve. So for tables, again, we'll stick to create table as far as the main body of the table is concerned. In order to enable special options like change tracking and so on, you can do an alter table. But if you try to do, or if you, the specific thing is, if you wanted to add a change, like you want to add temperature into this table, right? What you mentioned is a very important consideration. So if I do this, if I add temperature into the middle of the table, and let's say decimal, and something like this, what is going to happen is, because I changed the table ordinals or the column ordinals within the table, DACFX, when it does the schema difference and detects that there's a new column in the middle of the table, it's actually going to, by default, it's actually going to create a new copy of the table, then do a select, insert select. It handles all of that internally, but it's going to be expensive because it's going to take time to create the new table, move the data around, and so on. So one of the things we always suggest for people working with SQL projects is add columns to the end of the table, because it does make a difference in the way the deployment is done. The other option you have, and this is kind of getting a little detailed, but but when you do when you do a deployment, so if I just simulate this really quickly, there is a way to ignore column ordering. So what you can do is you can say, hey, when I'm deploying, there's actually a way here. If I can
ignore tab. Yep.
Right. So you go to ignore column order, and ignore column order will allow you to, then it won't do the thing that I mentioned, which is it won't move the table data around. So there's lots of little optimizations that you can do. And that is part of the, I think, again, to be pragmatic, I think SSTT and SQL projects has evolved over many years. It is almost, I think, toward 13, 14 years since it was first introduced. And over time, it becomes, it becomes very capable. It's also a little bit more complex, because just take a look at all those options, right? There are so many. So people sometimes get overwhelmed with the amount of complexity that's possible with SSTT and DACFX, but it's not necessary all the time. Most of the time, it just works. But if you really need to tweak behavior of DACFX, you could do that as well. So long answer to maybe hopefully it did explain. But let me quickly show you how. So this was the baseline database, or the baseline table. To save on some time, what I'm going to do is just git checkout. I'm going to go to a branch where I already made the change. Sorry, add temps, which is so as you saw, magically this new column appeared, which is because I already introduced the change in a git commit. And I just switched to that branch which had the git commit. So the new git commit has this new column, and it also has the new column reflected in the stored procedure. And I think we add some sample data. I'm not sure if we do that here or not, but yeah, so pretty much we just change the table and the stored proc definitions as a create, and SQL projects DACFX will internally generate an alter for you. The other thing I want to show you very quickly, because we are almost out of time, is code analysis. So if I run code analysis on on this database, I actually have loaded those free third-party options that I mentioned briefly. So as you can see, there's a bunch of these third-party things. These are all different projects. So the ones that I'm highlighting come from the third-party options. These three, the ones that I'm expanding now, come for free and within SQL projects by default. So you already have a lot of rules if you don't want to go to third-party options, which flag certain very common anti-patterns, like somebody using a percentage sign inside a like predicate, which is at the beginning of the string, and that's a bad pattern, right? Because it'll do a scan of the table or index in concern. So there's a lot of these rules, and the other third-party projects actually add like more than 100 rules to what's already there in SQL projects by default. So I think it's a very, very powerful capability when you have the need to do that. And while DACFX and SQL projects do have their learning curve and a little bit of this overhead, as I mentioned, from a deployment perspective, they have a lot of potential as well from code review, from a project ecosystem point of view. For example, if I wanted to kind of navigate and let's see if I can show you a very simple example of this. I could change columns here, and I can say, hey, rename this column to temp. Let's just pretend I'm changing it. And when I'm changing it, it's actually going to say, hey, you also have a stored procedure, which has that column. So you got to change that as well. And it's going to do the change for you. So you don't have to change it. So there's a lot of advantages when you do work with a SQL project inside of Visual Studio. It's very sophisticated. It does have the learning curve, but there's trade-offs, right, between the sophistication and power that it offers and the associated compute and learning curve overheads, if you may. I'll quickly end my demos with showing you Azure DevOps. And again, this is going to be a little bit of a crash course, but I think again, Azure DevOps is a big topic in itself. So this is Azure DevOps. For the world, for the quick walkthrough, I'm going to just show you a couple of things. So this is a free project, by the way. I created this as a free Azure DevOps organization, so I don't have to use a credit card, and it's free for demo or organizations which are smaller in size. When you create a new organization, you can create a new project within the organization. Within the project, you have different options, and each of these options correspond to one of the phases in the life cycle that we described early on. So boards, as an example, corresponds to the planning phase. So for example, you can see your backlog. You can actually see here I have a Scrum, like a Kanban type board, where I have user stories, I have tasks, and these tasks are assigned to developers to fix, and they can do their job and keep notes in the task. So that's boards. You can view other things within the boards option. Then you have repos, which is where you keep your code. In this case, I have two repositories. One is the wide world importers sample, which most of us are familiar with from a SQL perspective. But the fitness repo is where I am working with. And as you can see here, there's plenty of specific things you can do with it. You can do branching, you can do pull requests, which is the standard way of working with Git and GitHub. If you're working with any kind of changes, you'll create a pull request. So in this case, the pull request, the key things I want to call out are it's easy to integrate with your workflows. So my workflow here involves that I need a code reviewer to approve the change. And without the code review, I cannot merge the pull request. So this is institutionalized, right? You have a formal process of code review, and then the workflow depends on the code review to be approved before you merge. The other thing is pipelines. So pipelines is where I want to just focus on briefly. So pipelines are just like GitHub workflows, wherein you have a set of stages and a set of activities within the stage. So this example here, just show you the pipeline here itself in the browser, is very similar. If you first looked at the pipeline, it's in YAML, which is the syntax of choice for pipelines. And again, it's being triggered whenever there's a pull request. The difference here is it's running not on Windows latest, but it's running on a self-hosted virtual machine. So Steve, again, going back to your previous question about can I run this against a VM which is running on my on-prem private cloud or something of that sort? Definitely you can, because this Azure self-hosted VM, for example, in this case, it happens to be hosted in Azure. So this is actually the VM. It's running Visual Studio, and it can connect to Azure DevOps, and it can connect to my corporate environment as well. And all the other features that you're used to from GitHub Actions point of view are available here as well. So in this case, secrets as well is a library. So let me briefly show you that and come back to the pipeline in a minute. So secrets, you have all your secrets, like you have the server name, you have the username, password is masked for obvious reasons, and then you have a web application SQL password as well, which again I have masked as a real secret. So all these secrets can be used in your pipeline. So let me skip forward into the key things. So this is like MS Build. We used a slightly older task in this case, which is called VS Build, but it's just like MS Build. It builds your project. And what comes out of that build is a DAC pack. A DAC pack is what is used to deploy into the SQL Azure database, which is internally done using this task, which is called a SQL Azure DAC pack deployment task. That task itself uses some of the secrets that we had set up, as you saw briefly, the username, the password, the subscription name, and so on and so forth. And what this ends up doing is it runs SQL package, which is actually DACFX under the hood. So let me show you the outcome in the end of the day, because that's really the most important thing to take away from this little demo, which is let's actually look at these steps in brief. So the first step was checking out the project. It's not interesting. Let's skip that. The second step is to build the project. So as you can see here, there's a lot of output. And this output is just like what you get when you build a SQL project with your Visual Studio. And as you can see here, it's internally using Visual Studio for you to build the DAC pack. What it produces at the end of the build step is the DAC pack file itself. The next step is to take that DAC pack and save it as an artifact. An artifact is very useful because it saves the history in the pipeline output, if you may. So if you want to go back and see what did I deploy as part of this pipeline, I can go back to the pipeline itself. So if I rewind a bit, you can see here we have the pipeline artifacts, and the pipeline artifacts includes the DAC pack that was built. So if you go down here, release, that's your DAC pack. So this is, again, going back to my very initial slides around what are the key characteristics of DevOps. You want to have repeatability, you want to have a lot of other things, but you also want to have an ability to audit. You want to go back and see what did it actually run, what was produced as a part of a build output. So you have all of these artifacts which allow you to track exactly what happened as part of a deployment cycle. And the last but not the least is actually deploying the backpack to the Azure SQL database. So in this case, as you can see, it's running this internal tool called SQL package.exe, which is part of something called DACFX. And all that it's doing is it's internally connecting to your database, which is possible because you fed it the secrets, username and password and so on. And then it actually creates the table because it's a brand new deployment. This is run a few days ago again. It creates the database for you, which is the baseline database. So I think this is very useful because in the end of the day, you can see exactly what changed. And there are options on SQL package to produce more verbose output. If you wanted to save that to a file for the record, you could do that as well. So DACPACs are they're very capable, and keep in mind some of the trade-offs that we mentioned. They're sophisticated, they're capable, but at the same time, they have that overhead of compute in the sense they need a little bit more time to reverse engineer the database and so on and so forth to do the actual deployment. So I just wanted to present these options to you. And what I presented is these two most popular options, which is the simple one, relatively simple one, which was using VS Code, DbUp, and then a little bit more complicated one, which was to use Azure DevOps with Visual Studio, SQL projects, and so on. I'm almost done, so let me move quickly and kind of wrap this up. So a couple of things. I think we've talked about this briefly. DevOps versus GitHub, as you'll see, they're very similar, but they're also slightly different. I think in the end of the day, there will be convergence. We're seeing some of that happening already with the VM images, the VM that are actually used. They're all shared. The syntax will hopefully come closer to each other, but you just be aware that they're slightly different at this point in time. A couple of links are provided on this slide deck for your reference if you wanted to know more. There's some specific tips. Again, I talked about one of these already in my presentation based on Steve's comment. This ignore column order setting, just be aware of that. In general, if you're working with SQL package and SQL projects, whenever you're modifying tables, add columns at the end of the table. Don't add them in the middle because then you might get data movement. There are lots of customizations possible with DACFX. You can write code to modify the way the schema changes are deployed and so on and so forth. So again, I don't want to get into depth because these are more for reference. And specifically for SQL DB and Azure, one of the tricks that I've seen some customers use, and I think it's a very nice way to minimize the impact of deployments. So when you're doing these deployments, there will be an impact to workload because you're going to do an alter table of some sort, or you're adding indexes and so on. So at the time, there are many sort of characteristics that people use. One of them is to redirect workload to being only read only for the time of the deployment. So you could say, hey, I'm doing a deployment. You can read and view stuff on the site or on the application, but you can't change things during the deployment. And when you're doing that, just be aware that in Azure SQL, if you have hyperscale or if you have business critical or premium, you can redirect read-only queries to a replica. So there's options out there if you're working with Azure SQL DB. All right, so I covered a lot, and I don't expect everyone to take away like a level 300 understanding of this stuff, but just keep in mind two things. If you want to summarize, I hope you got the gist of what DevOps is, what you can do with Azure SQL in the context of DevOps. And just keep in mind, there are so many options out there. I showed you some of the ones which are possible, but you can mix and match whatever suits and meets your requirements. And a little thing, I already mentioned this, even if the project says SQL Server, these tools work great, even if it's SQL Server or whether it's Azure SQL. So just keep that in mind. It's a little silly thing, but it's important. I provided a lot of references which you can go through at your convenience. And if you have questions, as I mentioned, do get in touch with me via Twitter. It's probably the easiest way to get a hang of me. So I'm going to leave again That's my Twitter handle. I hope you enjoyed this presentation. If there's any questions, let me know. Otherwise, it was a pleasure talking to you all.
Arvind, can you go back to the contact form, to your contact information?
Yes, sir.
Awesome, thank you.
That's me.
Yep. Question about deploying GitHub or Azure DevOps to, let's say, AWS RDS SQL Server. Is it an option?
In principle, yes. So let me quickly go back to this thing. So let me make sure I understood the question. You said Azure DevOps to RDS, right?
Yes, or GitHub.
Or GitHub Actions, either of the two. I think it will work because in the end of the day, the deploy DACPAC task, all that it needs is a SQL Server endpoint. That SQL Server endpoint could be running as a VM, or it could be running as a SQL DB, or it could be an RDS instance. The catch is you need to have connectivity to that instance. So if you're comfortable opening up 1433 to the public internet or to a specific set of IPs, then sure, you can potentially target like a RDS instance, which is and it should work because in the end of the day, it's just a connection string. What you could do is I briefly mentioned this, but I can go into details if you're interested. I mentioned that I am running a self-hosted VM, which is running my Azure DevOps agents. So this in Azure DevOps, I can create a VM and say that it's a self-hosted agent. If you could deploy such a VM into EC2, for example, which is on your virtual private network or whatever they call it in AWS, which can talk to your RDS instance, you could potentially use this methodology to deploy changes safely and securely into RDS as well. It should work. And you could use DbUp as well or some other third-party library, because that's even simpler because it just needs a connection string. And as long as you have network connectivity, so firewall rules, or you use a self-hosted VM like this with Azure DevOps, it'll work. With GitHub, you might, I'm not sure. I haven't used GitHub Actions and like an equivalent of self-hosted VMs with GitHub Actions. It might be possible, but that's something we have to check offline.
What about permissions? Does it require sysadmin, for instance?
It depends on the deployment that you're doing. So generally speaking, we will assume that you have a DB owner, at least for that database that you're targeting. However, if the nature of your changes is very specific, and again, if you're doing the build your pizza type thing with something like DbUp, it may be possible to customize permissions to a minimum level that's needed, like a DDL admin or something which just changes DDL, like issues DDL. So I'm not totally sure what. So in an Azure SQL DB context, for example, there is not a concept like a sysadmin in usual sense of things. Generally, we will work with the DB owner at the most within the database. So it should be narrow scoped and it should be possible to customize further.
Got it. Thank you.
Okay.
I think this is all the questions. Arvind, thanks a lot.
Okay.
This was a great presentation. I personally learned a lot. Hopefully, attendees learned a lot as well. Thank you, and I guess see you in person or remote next year at the SQL Server in Los Angeles.
Yep. Thank you, sir. Thank you for the opportunity, and everyone stay safe. Thank you for your time. Bye-bye.
Thank you.